Got a question about that list of self-test exercises at the end of chapter 6. That is, of course, material for the quiz, the end of module quiz, module 3. Anyway, let's think about this. Many states are now imposing severance taxes on resources being extracted within their borders. In order to understand the effect of these on the allocation of the mineral over time, assume a stable demand curve. A, how would the competitive allocation of an increasing marginal cost depletable resource be affected by the imposition of a per unit tax, let's say $4 per ton, if there exists a constant marginal cost substitute? So, and then B, comparing the allocation without a tax to one with a tax, in general terms, what are the differences in cumulative amounts extracted and the price path? So how do we tackle this? So we'll tackle it just the way we tackled similar questions in the chapter. And that is going to be, we're going to just imagine what it looks like in the two-period model and then take the lessons we learned by studying the two-period model. We'll take those lessons and apply them to the indefinite model. So here we go. I'm going to create a new page and set up the two-period model. All right, here's our two-period model. I don't have it yet, but let's just draw it out. We've got this set of axes, marginal, present value and marginal net benefit in period 1, present value and marginal of the marginal net benefit in period 2, PV, MNB1, PV, MNB2, and we'll assume it's just a constant demand over time, the easiest case. So here we'll have, it's increasing cost, so we know it's a scarce resource. That's code. And let's say we have one function in period 1 and another function in period 2. It's discounted, so it's going to have the same total amount of the resource. So those, if we're counting from the left, this point here is going to be the same as if we're counting from the right in quantity at this point here. All right, so far so good. We know that the outcome, when there's no tax, we're going to have this outcome. This is Q1, and we know that that's whatever the stock of the resource is minus Q2. And recall that Q1 is a little bit bigger than Q2, and the marginal user cost is the scarcity rent is like so. So what's going to happen in the tax? Well, the key to this problem is to see that a constant in the $4 per ton severance tax is going to have a similar effect in both periods. It's going to reduce the marginal net benefit, whatever the marginal net benefit was before. It's going to be $4 less, and I guess that would go through all the way across. So we're going to write the new system in blue. It's going to be $4 lower in period 1, and it's going to be a discounted $4 lower in period 2. And I haven't done the math. That's supposed to be a straight line, but pretty much they intersect at exactly the same quantity. Maybe there's a shade, a slightly different quantity, but pretty much the extraction is going to be the same. What's going to change is that there's going to be a lower scarcity rent, a lower marginal user cost. That's the main outcome. So we'll call that MUC prime. So what does this mean for our time paths? Well, one is that the rate of extraction, the allocation of extraction across periods isn't going to change very much, if at all. But two, the marginal costs are going to fall. The marginal cost of the marginal user cost, the scarcity rent, is going to fall. So the total marginal cost, the extraction cost plus the scarcity rent, that function is going to be lower. And so what's that going to mean? Here, let's look at that. We're looking at the case where there's a transition to a renewable resource. And what the result of our analysis is that the main event here is just going to be a reduction in our marginal user cost, which is a reduction in our total marginal cost. That's going to make the transition to the renewable later. This extraction cost, we'll assume, is the same. And what that also is going to do is it's just going to increase the total amount of the depletable resource that we're going to extract before we switch over to the renewable. So that's a little bit counterintuitive. Once you have a dynamic model, the effect of some of the taxes that you might be considering in a static environment, your thinking might change, because that by slowing down by diminishing the marginal user cost, the signal of scarcity to producers, you may end up perpetuating the reliance on the renewable. So that's an important consideration. What to say here? The other point to make is that this is the effect of the tax on the price the seller receives, not the price the buyer pays. So the price the buyer pays would be going up, but the money the seller receives goes down, and that has the result of reducing the marginal user cost, the scarcity rent. So it's a little bit counterintuitive, sort of an interesting problem.